Consider two vials of liquids. One is filled with honey and another is with water. Now I am going to pour out the liquids down. What will happen? Water will easily slide down when compared to honey. But how water slides out so easily? Because honey is more viscous fluid and water is less viscous. This means the honey has more internal friction and it will take longer time to pour out of its vial than the water. A fluid with a higher viscosity will have more friction between its particles, meaning it is harder to do things even to stir it. So, viscosity is a property of fluids that affects the movement of fluids and other objects' movement through the fluids. Specifically, viscosity is the magnitude of internal friction in a liquid. Now, we will discuss the viscosity deeply. Consider water enclosed between two glass plates, as you can see here. The bottom plate is fixed while the top plate is moved with a constant velocity v relative to the fixed plate. If water is replaced with the honey, as you can see here, what will happen? It is very hard to move the glass plate. So, greater force is required to move the plate. Hence, we say that honey is more viscous than water. Actually, liquids have a number of layers. The layers of the liquid in contact with top surface moves with a constant velocity v, and the layer of liquid in contact with the fixed surface is stationary. I will explain the movement of layers in liquid with an example. Consider a big size block of jelly which is in the top of a table. Now, I am going to place my hand at the top of the block and I will apply some force. You see that only the top part, as you can see here, only the top part of the block moves significantly. Consider the points in the block of jelly A, B, C and D, as you can see here, A, B, C, D. Due to the force, the shape of the block of jelly has changed, which is denoted by the shape A, E, F, D. We already know about the mechanical properties of solids and also the ratio of change in dimension to the original dimension of a solid is called strain. A similar response is also seen in liquids. The difference being that liquids show large changes in shapes even for very small forces. Let the displacement of the points in the upper part of the liquid layer is delta x. During this time interval, the liquid has undergone a shear strain delta x by L. Since the strain in a flowing liquid increases with the time continuously. The rate of change of strain or strain rate is given by delta x by L into delta t. We know that delta x is equal to v into delta t. So, the above equation now becomes v by L. We can easily calculate the coefficient of viscosity. The coefficient of viscosity for a fluid is defined as the ratio of the shearing stress to the strain rate. Shearing stress is the force applied per unit area. Shearing stress is equal to the force by area and already derived by the shearing strain is V by L. So, the coefficient of viscosity eta is equal to shearing stress divided by shearing strain. By applying shearing stress divided by shearing strain, equation becomes eta is equal to F by A divided by V by L, which is equal to FL by VA. The SI unit of viscosity is Poisson and its dimension is m times L to the power negative 1 times T to the power negative 1. All real fluids except superfluids have some resistance to stress. But a fluid that has no resistance to shear stress is known as an ideal fluid or inviscid fluid. So far, we have discussed the viscosity of fluids. Viscosity plays an important role in our daily life. In our body, the viscosity plays a large role in blood circulation. Do you know the relationship between viscosity and a raindrop? Are you excited to know that? Let us see it in the next video. Now, let us summarize what we have learned so far.
Manorama Horizon. Learning made simple.